Hello, it's Friday afternoon, and these are the notes for Monday, Integrated Math 1, third quarter, week 4. We're talking about sequences. Our objective for Monday is first, know what a sequence is. What is a sequence? The second objective is be able to determine what type of sequence you have. So if you're given a sequence of something, what type of sequence do you have? And then the third objective is be able to make a sequence from a story or a picture. So our first one, a sequence. What is a sequence? A sequence is a set pattern that can end or go on forever. Let me give you an example. I'll give you one that can end. What is this sequence? Do you know the rest of the sequence? Because it ends soon. Now, the sequence does repeat itself, right? It will go back to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So it can end even though it goes on forever. It's a repeating pattern. What about a pattern that never ends? Well, let's look at this first one here, arithmetic. What does it mean to have an arithmetic sequence? Well, an arithmetic sequence is a sequence where you add the same number to get the next term. Add the same number each time. Add the same number each time. The number that you're adding is called the common difference. The number you add. That's the number being added to the sequence. For example, let's take this one. Here's a nice little sequence. 2, 4, 6, 8. How does it go? At this point, we know that each time we're adding 2. Adding 2. Adding 2. If you're adding the same number over and over again, it is an arithmetic sequence, and you now know that the next one should be 10, then it goes 12, etc. The 3 dots, this is called an ellipsis. That means it goes on forever. Those 3 dots tell you that it continues. That's an arithmetic sequence. What if the arithmetic sequence is doing this, though? Let's try another one. Well, it says, I told you that an arithmetic sequence is a sequence where you add the same number each time, right? But this one does not look like it's adding. It looks like it's subtracting 5. Well, the rule is you're adding a negative 5. You can look at it and think about it as subtracting, but you're adding a negative 5 each time. So the next number in this list would be, add negative 5, we'll be at negative 3. And it goes on forever. That's arithmetic sequence. In a nutshell, the numbers go forever. You're adding the same number even if the number you're adding is negative. So what about a geometric sequence? That's our next one. Geometric sequence is a sequence where you multiply by the same number. Each time. So arithmetic was all about adding the same number each time. Geometric sequence is all about multiplying each time. The number you multiply by is called the common ratio. This is the number you're multiplying by, the number being multiplied. Well, let's look at one. Here's an interesting one. Maybe 1. That's my first number, right? That's my first term of a sequence. I should add the word term to our vocab list. 1, -3. And you're thinking, wait a second, didn't you just subtract 4? Well, I told you it's geometric. What do you multiply by a 1 to get a -3? Well, I'm going to multiply by that same number again. I'm going to get a +9. I'm going to multiply by the same number again and get -27. I'm going to multiply again and get a +81. And the sequence goes on forever. And you're saying to yourself, what did you multiply by? I multiplied by a -3. -3 times -3 is +9. 9 times -3 is -27. Times -3 is 81. So this is multiplication going on here. I wrote the word fraction. That's important because what if you see something like this? And I'll change color a little bit. 16 and 8. Well, if this is arithmetic, I'm subtracting 8 or adding a -8. But I told you it's geometric. In which case, what am I multiplying by to go from 16 to 8? And if I multiply by that same number, I get a 4. Multiply again, I get a 2. Multiply again, I get a 1. Multiply again, I get a half. Well, what I'm multiplying by is a fraction. You're thinking to yourself, isn't he dividing by 2? To divide by 2 is the same as multiply by a half. Dividing by 2 is multiplying by a half. So my common ratio is times 1/2. I'll put a little times symbol. Times 1/2, etc. And it keeps going forever because I can have 1/4, 1/8, 1/16, and continues on. So I said I was going to bring up one more vocab word, and that was term. Let's see if this is movable. No, it's not. So the word term is the word term every one of these numbers in the sequence is a term. This is my first term, second term, third term, fourth term, or term number 4. This one over here is term number 5. So the terms are the members of the sequence. And you have a first term, and then you have the rest of the terms. Okay, I want to look at numbers 1, 2, 3, 4. Which one is arithmetic, which one is geometric, and which one is neither or neither? So you look at it and say, okay, maybe I'm going to blow this up so I can see it a little bit better. I'm going to check for arithmetic first. 21 plus 7, 28 plus 7. Okay, it looks like I've got a arithmetic here. 35, 36, 37, 38, 39, 40, 41, 42. Yep, plus 7. This is arithmetic. I'm going to ask you to do this today on your assignment or on Monday. So tell me it's arithmetic. I want to see your work. This is your work. You show me this thing going on under the numbers, and you show me, oh, I'm adding 7 each time. Well, let's look at the one below it. This is adding 90. This is adding 900. Okay, that's not arithmetic because it has to be the same number. What about multiplying? Well, 13 times, no. Nothing multiply. This doesn't multiply. It's not. This is an either. It doesn't work. I can't multiply anything in between to get the same number multiplying each time. Doesn't work. Okay, 4. This is going to be minus 25 plus 120. Okay, it's not arithmetic. Erase that. Let's try another one. Let's try geometric. 4 times 5, well, 4 times negative 5 is negative 20. Negative 20 times negative 5 again is 100. I think I found it. 100 times negative 5, this is easier. 5 times 100 is 500 times a negative, negative 500. So this is geometric. Geometric. Okay. And show me your work, just like that. This last one, number 4. Is it arithmetic, geometric, or neither? This is plus 2, plus 4, plus 8. Yeah, it's got to be the same number in order to add. And I can't multiply any number by 3 to get 5 and the same number to get 9. So this is neither. This does not mean that it's not a sequence. It's just not arithmetic. It's not geometric. Because there are many, many other sequences out there. And just so you know, I'm going to give you one of them, one of the most famous ones right now. This is a very famous sequence discovered 800 years ago, I think. Can you understand or figure out what the sequence is? How does it work? This sequence is found in nature. Just so you know, it's a real sequence. It's famous, discovered by, I might be spelling his name wrong, Fibonacci. I can't remember if it's 2 B's, 2 N's, 2 C's. It's somewhere in there. But I know how to say his name, Fibonacci. The sequence is named after him. Okay, last one. A sequence from a story or a picture. This is supposed to be a story about wallpaper or a design on around a book or something around a room. Do you see the pattern going on in the sequence? I can write the sequence as numbers. I'm looking here, I'm looking at the column. It goes 3. The next one is 4, 2, 3, 4, 2. It looks like a repeating sequence. Can you tell what the next one is going to be? Well, I think we're going to have 3 of these flowers. Then we're going to have 4 of these flowers. Then we're going to have 2 of the flowers. Could you draw it? How about this pattern? This is also a very famous pattern. I believe it might be named after a guy named Sierpinski or a guy named Pascal, or both. What's happening? Maybe I'm counting the number of black triangles. I got 1, and I got 3, and I got 6. Okay, right now I've got plus 2, plus 3. Okay, this is not arithmetic. I've got times 3, times 2. It's not geometric, so this is neither sequence. I'm seeing that this is being added to the bottom. This is right here. This one is right here, and the bottom is being added. Same with this. This one is right here, and the bottom is being added. So 6 plus 7, 8, 9, 10. I added 4. This is plus 4, plus 3, plus 2. I see the pattern here. So I'm probably going to add 5 to get the next shape, plus 5 to get 15, plus 6 to get 21, etc. It goes forever. It's a never-ending sequence. Now I got one about a pizza. Jacob is participating in a pizza making contest. Each contestant has to bake the largest and most delicious pizza they can. Jacob's pizza has a 6-foot diameter. Wow. After the contest, he plans to cut the pizza so that he can pass the slices out to share. He begins with one whole pizza. That's what this table is for. Here, see this whole, he starts with one whole pizza. Beginning, one slice. Then he cuts it in half. So he cuts, now there's 2 slices. There's slices, and this is the term. After that, he cuts each of those in half. So the third time he's doing his cutting, he's got now 4 slices, because look, here's my picture. There's my first term, second term, third. See, there's now 4. Now I'm going to make the 4th term. He's cutting both of them in half. So my 4th term has 1, 2, 3, 4, 5, 6, 7, 8. 8. The 5th term, I'm going to cut each of these in half. So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 16. This is my 5th term. 16. I see the pattern. From here to here, times 2, times 2, times 2, and times 2. It goes on. This is never ending. It's geometric. And let's see, is there anything else? Nope. That's it. That's what I want us to be able to do on Monday. All right. Enjoy the rest of your weekend. Hopefully you watch this before school on Monday.